And the new thing for today is definite integrals, meaning we've got limits. A and B. So we won't have plus C as an answer, but we will have to plug in the top minus the bottom. For definite integrals involving u-substitution, it's sometimes convenient to determine the limits of integration in terms of the variable u. Okay, this is changing the limits. You have to change everything. All the x things have to be u things. We talked a little bit about that yesterday. So the integrand needs to be u stuff, the dx needs to be du, but now we also have to think about those limits. As it's written, that's from x equals 0 to x equals 1. So if we change all this stuff to u stuff, we also have to change the limits to u limits. Now, there is a bit of a choice, and I will show both. You can keep the original limits and revert back to x. So like switch your whole problem back to x and then use the x limits. Or change the limits to u values and plug those in, and you don't have to plug x back in at the end. If you're trying to think which one's easier, it doesn't really matter. It's the same amount of changing. It's just if you want to put the x stuff back in so that you can keep the limits, that's an extra step. Or do you want to change the limits to u limits? That's an extra step. But then you don't have to sub the x stuff back in at the end. I'm usually going to use number 2, which is changing the u limits, changing the limits to u things, because we can ask test questions that force you to do it this way. So I'll show it both ways, but I'm usually going to do it method number 2. Okay, so let's start number 1. It starts the same. I don't have to worry about the limits initially. I just want to figure out u and du and see if I can get things switched around to u. So, Ben, what do you think would be a good choice for u in number 11?
1 minus x squared.
Good. Because, Abby, what's du?
Wait, yes, sorry.
What's the derivative of negative 2x? Or negative 2x dx? Abby, is that good news? Like, does that mean Ben picked well?
Yes.
Yeah.
Turn the x into, or multiply by negative 2.
Yep, I just need an extra negative 2 in there. And that means I need a negative 1/2 out front. But that's easy fix. It's just off by a coefficient. No problem, we can fix that. So that negative 2x dx, that's du. And then Ben correctly suggested that stuff be u. I'm going to change it to a power of 1/2 because I don't like taking antiderivatives of square roots. I'd rather do powers. Okay, now you might notice that what have I left off? Those limits. And the reason I've left them off is if I write them down right now, this is technically an untrue statement because this is from x equals 0 to x equals 1, but now I've switched over to u. So I'm going to change my limits. So that top limit is 1, but that's x equals 1. If x equals 1, so I'm working on changing that top limit. If x equals 1, what does u equal? Yeah, I'll plug in 1 for x. 1 minus 1 is 0. So now my top limit is 0. Is u equals 0. It went from x equals 1 to u equals 0. And if you really want to get wordy, you can even label that x equals 1 and u equals 0. All right, how about my bottom limit? If x equals 0, what does u equal?
1.
Yep. Okay, that maybe looks weird. It looks like they just traded places. That doesn't often happen. That's just a fluke that it looks like they swapped. We plugged in x equals 1, we got u equals 0. We plugged in x equals 0, we got u equals 1. So now we've changed this entire problem from an x thing to a u thing. This looks a little bit weird. Anybody not like how that looks, or why is that weird? I don't like 1 to 0. That feels backwards. So I can flip it if I'll change the sign. So I think that's worthwhile, especially since changing the sign will make it positive anyway. So now I've switched everything over to u. So now I don't have to worry about x's at all. Let's see. Jace, how about the antiderivative of u to the 1/2?
2 over 3 u to the 3.
Yes. And then I don't have to put my x stuff back in because I have limits with u on them. So I'm done with x's for this problem. I'm just going to finish it out in u terms. So 1/3, 1 to the 3/2 minus 0 to the 3/2. That's a safe stop, right? So if you're worried about weird exponents, although surely 1 and 0 aren't a problem, but if there were weirder numbers in there, that would be a safe stop, and you could leave that alone. But 1 minus 0 is 1, and so my answer is 1/3. So somebody explain to me, how is that different than what we did yesterday? What made this problem different than yesterday? What was different about it? Had to plug in the limits. Yesterday we didn't even have limits. Today we have limits, and we have to be careful because we have to make sure we've switched to u limits. The other option, I didn't even do option 1 on this one. I did option 2. Option 1, I don't have room to do it. Right about here, I could put the 1 minus x squared back in and use my original limits. But I think it's better to switch the u limits. Switch to u limits. Number 12. Let's see. Alex, what do you want to pick for u? What do you think would be a good choice? Good, x squared plus 4. I think that's going to work for us. Avery, what's du then?
2x.
Good. So, what does that mean for Alex's choice of u? Is it a good one or not a good one? That's good. It'll work. You just need a 2. That's an easy fix. 2 and 1/2. Again, I'm intentionally leaving off those limits because I'm in the process of switching to u, so I don't want to put x values there when this is turning into a u problem. Okay, I guess I've got options here. I need to switch the limits. I also don't like the square root thing, but let's do the limits. So, if x is square root of 5, what's u? When x is root 5, what is u equal to? 9. I just square it, I get 5 plus 4 is 9. So my new top limit is u equals 9, not x equals square root 5. And then my bottom limit, same process. I'm going to plug in 0 for x and get 4 for an answer. So now my new bottom limit is 4. And I like this one better than that last one. I don't have to flip anything. 4 to 9, that's going in order. I like that. Some of you would take this integral right there and be okay. Others would like to see it written as a power first, because that makes the antiderivative, I don't know, I like to write the steps rather than put them in my head. Just trying to help Jake out. Jake, what's the antiderivative of u to the negative 1/2?
2u to the half.
2u to the 1/2, yes. And then we also have that 1/2 out front, so those will cancel. And again, because I've switched my limits to u limits, I'm ready to go with this problem. If I wanted to keep those original x limits, I'd have to put x squared plus 4 back in there, and then I could use 0 and root 5. But I don't want to go that way. I've already got the u limits, so 9 to the 1/2 minus 4 to the 1/2. That's a safe stop. But that's also just 3 minus 2 is equal to 1. Okay, I want to show the other way. I don't think I even want you to write this down. So just watch me use method 1 here. That would be, I'm going to plug in the x stuff back in for u. So x squared plus 4 to the 1/2. What are my limits, though, if I want to revert back to the x stuff? What limits will I use? Yeah, square root of 5 and 0. Because now I'm doing an x problem. So let's see, root 5 squared is 5 plus 4 is 9. 0 squared plus 4 is 4. 4 to the 1/2. And you can see we get the same thing. So you can switch it back if you want. Which, the switch back method means you don't have to find the u limits, but you got to switch it back. The u limits method is you got to find the u limits, but you don't have to switch it back. So it's a trade-off, but it's kind of the same thing either way. Again, I think switching limits is better because I will ask test questions that force you into, in fact, we'll do one together in a minute off today's assignment, that will force you into doing it the method where you change the limits. All right, 13. I think I'm peeking ahead. I don't like that 4 there. I don't think that's going to work. Kenneth, what do you want for u? For 13. Good. I say good. We don't really know that it's good until we sort of finish the whole process and have everything work out, and then we'll know that it's good. Addie, what's du then? So now I would say the Kenneth's pick was good because I've got an x squared there. 4s and 3s. What do you want to do to make that work? This is why I didn't let you do this one on your own. How do you want to turn that 4 into a 3? 4/3.
4/3 on the outside.
Okay, 4/3 on the outside, 3/4 on the inside. The other option is, you know what, forget that, just put the 4 out front, and then a 3 on the inside, and a 3 on the outside, and then you've got 4/3. So either way. So 4/3 on the outside, 3/4 on the inside so that you land at 3. And so now you've got 4/3 integral u to the 1/2 du. I'm going to press pause and let you see if you can go from there. Okay, questions on that one? Autumn, what do you think for 14? What would be a good pick for you? Good. Why did you pick cosine rather than sine?
Because it's more complicated.
It's a good answer. It's more complicated, so you'd rather clean this part up than clean this up. The other answer, that's a good answer, is if you pick sine, and du is cosine, but then you've got some square root to have to deal with, and you can't do that with a dx and a du. So you picked right. Du then is negative sign, so that messes things up a little bit, but certainly better than dealing with the square root. All right, once again, I'm going to pause and see if you can go from there. So, like, where did this negative come from, or where does it go? Where does it go? Okay, let me back up and answer the first one. It comes from, like, I need the negative sign x, so I put in there and out there. So that's where it comes from. Where it goes is, that's a good question. I don't like 1 to 0. That's backwards. So I can flip those, and the only cost for flipping those is a negative sign. So, like, the cost to flip those is a negative sign, and then the two negatives make a positive. Again, you don't have to do that. It's just convenient on, like, two fronts. It gets them in the right order, and you get rid of the negative sign. Let's see, 2/3, 1 to the 3/2 minus 0 to the 3/2. And if you're really enjoying a safe stop, then you stop there and you're done. Hopefully 1 to the 3/2 and 0 to the 3/2 is not complicated for you, but why bother messing something up when you can safe stop it? I think I've said this before, but on the safe stop, you do have to get to where you plug everything in. You can't stop short of what I boxed in. You can't be like, oh look, I already took the integral. Like, yes, but plugging in the top and bottom, that's a calculus thing. So you've at least got to plug them in. Then you can safe stop. Okay, let's look at today's assignment, because I want to do a couple together that, again, you will see these again on my test and the AP test, 6 and 7. In some ways they're easier because you don't have to finish the problem, but you need to be okay understanding with, like, how to stop halfway through and find the answer. Let's see. I think 7 might be harder, maybe. Harder than 6. Using the substitution u equals sine of 2x. So they're telling you which substitution to use. That's kind of nice. This integral is the same as which one of these. So you don't actually have to solve the whole problem. All you have to do, like, it's easy. You have to switch all the x stuff to u stuff, but stop there. So why don't you see if you can do number 7. Basically, you work the problem like normal. It's just you're going to get to stop before you take an antiderivative. So answer choice D. What would make C correct? C's close.
The 1/2 was negative.
Yeah, if you wanted to switch those and make that negative, then C would have been right. And I was wondering if they were going to do that. They didn't. So answer choice D, it is. Because my du up here had a 2 on it, because derivative of sine is cosine, but chain rule is where that 2 comes from. So I needed that 2 to make du. So that's fine. I can put a 2 on there, but then I have to put a 1/2 out front to counter the 2. Is that better, Ava? Okay. Again, I promise you there will be a question or two like that on the test, and there's probably one like that on the AP test, although I can't promise that. But on our test, you will definitely see one like 6 or 7. And I think they're supposed to be easier problems because we tell you what u is, but sometimes students get confused because they want to work the whole thing, and then they end up trying to back up and, like, no, just work the problem slowly and look at your answers and pick out which one it is. Okay, I think the rest are more straightforward. There's another one like 10 and 11 where it tells you what u should be, so those aren't too bad. We can work on those tomorrow. So assignment today, worksheet 2. Again, get back on track, keep up with the homework so that you're prepared as we go. So, yeah.